Go ahead and read your word problem there and start seeing if you can get your picture set up. Joe and his family are going to Largeville. They board a plane at 6 a.m. in Smallville and start flying at a speed of 380 miles per hour and a bearing of 250 degrees. They stop at Midville for a layover at 7 a.m. and get back on board and continue to Largeville, traveling at a bearing of 130 degrees for 1 hour, 1 3/4 hours at a speed of 400 miles per hour. How far is Joe from home when he finally gets to his designation of Largeville? Alright, we're starting at Smallville. If you do not know which direction he's going, remember, I still think it's a good idea to put the little compass there, okay, at Smallville, and draw your line out, okay, so that we know that he's going at a 250 degree bearing. Which direction is that? Closer to north, south, east, or west? Pretty close to west. Remember our 0 degrees, 90 degrees, 180 degrees, 270 degrees. So our bearing that we have is just south of west. They travel out here and get to the layover designation of Midville. Okay, and they get back on their plane, and when they go to Largeville, they're traveling at a 130 degree bearing. Nolan, which direction is that going to be taking me if it's a 130 degree bearing?
Like southeast.
Southeast. Okay. So right here's 90 degrees. Okay, halfway in between 180 and 90 degrees is 135. So it's just shy of almost halfway. Now here's the part that you don't know. Is you got to kind of guess how far you're going to travel here going this direction here. Because if I go this way, it's going to kind of go back that way. Okay, if I go here, it's going to head up that way. Our bearing when we go back at home is going to differ on my picture depending on how far I make this line. Okay, and we debated about this last hour, and I said, well, we'll just guess and put Largeville right here. And this is the distance we need to find right now. Is that distance right back from Largeville to Smallville. All right, so in our picture, okay, I'm going to kind of draw it off here to this side. So I'm going to need 2 pictures. You don't have to do this yet. I just know last hour I got so much information in that picture that I kind of got confusing here. Okay, over here in this picture here, how far was it from Smallville to Midville? We started at 6 a.m. and got to Midville at 7 a.m. And how fast were we going for that hour? 380. So we were traveling at 380 miles per hour, and we started at 7 and ended in, started at 6 and ended at 7. So we're here at 380 miles. And so that's 308. Okay, from Midville to Largeville. It looks like we're traveling for an hour and 3/4. If I was to take your calculator away from you right now, could you do this without typing in 1.75? You should be able to do this without using your calculator. This distance from Midville to Largeville is, yes, an hour and 3/4. So we have an hour and 3/4. At a rate of 4, I made a nice rate here, 400. You know, we can't multiply 1 and 3/4 without our calculator. So I'm going to change this to 7/4. Nice part about this is when you cross cancel, you get 700 miles, is that distance. Okay, so we got 700 miles. What else do we need to put in our picture that we're missing? The turn angles. Alright, so here's where it sometimes gets, for some of us, practice is what you need to do. Okay, especially on part B. Okay, when you get this problem on Thursday on the test, make sure you know how to do the bearing problems. Okay, so as we're going down in this, there is many ways to go about doing these problems. And I have tried them. I've tried teaching them all. And this is the best, again, way I have come up with to teach the majority of you. Okay, as we fly down to Midville, this is going at a 250 degrees. So we're here at 250 degrees. I extend that out because what I want to know right now is how far am I going to turn? Well, when we leave Midville, we leave, flying at, what was it, 130 degrees. So you kind of have to pretend like, you went over top of Midville and you just kind of turned to 130 degrees. So you can realize how many degrees you actually turned, because you're going in and turning. Every degree is in a turn until we get to 130. Sandriti, how do we find out the number of degrees I turned? Okay, subtract them. So 250 minus 130 is 120 degrees. So Emily, is that what I put right here? 120 degrees into this picture?
No, it's not.
That's the exterior, right. So what do I need to do, Emily, to find my interior angle? Okay, so to find this supplement, right here we take 180 minus 120, which gives us 60 degrees. Oops. All right, I'm trying to get some space here to organize, so I put my little distance equals rate times time up here. Okay, because I need to find out this distance back to from Largeville to Smallville. Alyssa, can we use sine, cosine, or tangent to find that distance? Why not? Okay, no ratio. Ethan, can we use a law of sines to find this distance back to Smallville from Largeville? What do we need in order to use the law of sines?
We need
Ratio.
A ratio. Do we have a set ratio up here? No, we don't. Okay, so then we're here with, c squared equals a squared plus b squared minus 2ab cosine of c. We're at the law of cosines. So SL squared plus 380 squared plus 700 squared minus 2 times 380 times 700 times cosine, and this is where I'm running out of room, of 60 degrees. I saw some of you tried to watch the link of my bearing problem, and the link wasn't working, so I'll have to fix that. I'm recording this one too, so hopefully this one will be on the site fine. Alright, let's see here. Oops. Did I do that right? 144,400 plus. I'm gonna do that by 2 times. Alright, so then we have to multiply that by the cosine of 60. So a little bit of that by the cosine of 60. What are we going to get when we multiply by cosine of 60? A positive or a negative answer? A positive. We get negative answers for obtuse angles. Okay, so that answer will give us a positive, but we have a minus out in front. What did I say that was again? And I multiplied 530,000 times cosine of 60. What was it? I guess I have it right here. There we go. You can, yes. I'm just trying to show my work because I have more than one person kind of watching me right now. What was it again? 60. 266. Thank you. Alright, we get all that stuff down and we get SL squared equals, what did you guys get here?
36840.
Do the square root.
26.9596.
Alright. So Joe is, 606, about 607 miles from his house. Do we have any questions on that one? I'm not as worried about that part. The part I get worried about is losing that negative on the cosine. Okay, especially when it's an obtuse angle. Okay, not remembering to put it as a positive. Alright, the next part that I have is, okay, what's the bearing when Joe decides to go back home? Flying back home, maybe I'll put it in this picture right over here. What is this bearing when they're going back home right now? What angle is going to be needed to find that bearing home? Okay. What angle would we need to find?
The exterior angle, but to find that, you're going to have to find the interior angle there of
For-
MLS.
Okay, so MLS. So angle L is the angle we're going to need. We're going to need, actually, that's why it said here, we're going to need the exterior angle because that's actually the turn angle. But we can't find the turn angle unless we know angle MLS's interior angles measurement. So to find the bearing going back home, how do we find angle L's measurement? Sine, cosine, tangent, law of sines, law of cosines. Yeah. Law of sines. Okay, we do have that this right here is 606.9596 now. So we can use, okay, the law of sines. Sine of 60 degrees over 606.9596. That equals the sine of angle L over 380. Cross multiply and solve. Excuse me. somewhere around 0.5 something. Okay, so I took sine of 60, multiplied it by 380, and divided that by 606.9596. Which will help me find angle L's measurement, because that's the sine ratio. I hit second sine, and I come up with what type of an angle. How much?
32.
32.
0.833.
Point
833.
8331. Now, I forgot to talk about this last hour. And again, second hour is always my favorite hour, so I always remember to teach better that hour. Here's my point, though. Your calculator told you that. It was 32. This angle right here, what we're finding, is 32 degrees. But your calculator could have also said, okay, it doesn't tell you this, but it could be 32, or, okay, it could be the 147 degree angle, right? 140 and 7 point what? 1669. How do you know it's not the 147 degree angle? It says 147. I mean, just because. And this is going to make the difference between those of you that understand and get that A on the test, and those of you that, still will always put what the calculator tells you. Ethan?
60 degrees is 60 plus 147 degrees is.
Okay. If that's 60 and that's 147, we already know this triangle right here is bigger than 180. So there's your logic on it. It can't be the obtuse angle one. Okay? So your calculator tells you 1. You tell yourself the law of sines always gives you 2. We check both of them up here. The 32 degree angle is the interior angle. So now we have a turn angle out here. So we take here to find out this turn. Okay, right here. I'm going to take 180 degrees and subtract the 32.833. So in fact, we are turning at 147 degrees. Hannah, I'm done. That's my bearing. 147 to go back home.
So I added 200 for takeaway from
Okay. So add or take away. I'm just going to kind of come over here. I told you my picture's going to get really messy. So I drew this other one over here. I knew we were going at 130 degrees. We're turning at approximately 147 degrees. And we're turning at a counterclockwise direction. Does that make your bearing get bigger or smaller when you turn counterclockwise? Smaller. So if we're going to try to figure out right here what my bearing is, this is my turn amount. My bearing was a 130 degree bearing originally, and every time that we turn, we're making this bearing decrease. So it goes 129, and then 128, and then 127, and 126, and we do this 147 times. So we take 130 minus this 147.1669, and we get a final bearing here of,
negative 17.166.
okay, maybe not negative as our final. 'Cause I don't think we can have a final bearing because our bearings are from 0 to 360 degrees. And we got negative 17. What's that? Okay, so we have to know that this went beyond 360. So in fact, my picture right up here was not that accurate. Okay, you guys look here. I think I did a pretty good job yesterday of, or last hour of explaining this. They asked, why is this a negative 17? It looks like right here that it's 0 to 90. Well, here's what I should have done on my picture. If this is Smallville, and we go down here to Midville, like this, what I needed to really do is make Largeville a lot farther of a distance. See, it's 700 and it's almost as close in length as 380. So when I draw this back in this direction, if this is my compass right here, north, south, east, south, and west, right there, we know that we've gone beyond, on my bearing going back, beyond north. We've gone beyond it about 17 degrees. So to find out my final answer, I'm going to take 360 and subtract 17.1669, and we get an answer here of 142.8331 degrees. All that for one problem.
Well, there'll only be one of these in the test over.
There'll be a couple word problems, but only one that's, finding bearing and finding length of things. But you'll see a couple word problems. You saw some of them last night. What you had to do there. Some of those are very basic, very easy word problems once you get the information in the picture. And that's half of, any application problem. What are they asking me here? Where does this go? Where does that go? And you have to work your way through it. Okay, any questions here on bearing problem number 2? Our agenda for the rest of the week here is quiz. Tomorrow is going to be over 13.5. Okay, quiz.
Like the exercise,
Well,
Like the sheet or
it's going to be over more of the law of sines tomorrow, and then Wednesday we're going to have one over law of cosines a little bit more, and then Thursday we're going to have the test over this stuff. So this Thursday is the test over 2. Okay? So that's our agenda for this week. We have worksheet 13.5, number 1. You guys did the first 3 and then the book assignments, right? Okay. Your assignment for today is after you're done correcting, all of those problems from the book, is to finish up on that worksheet. Don't put everything away yet, because then I want to introduce the next worksheet. You only have to do the first couple problems on it.
So we have to finish this worksheet?
You have to finish up on 13. I'll write it down here when we're done. Okay?
do our corrections on Monday.
We will, yes. Okay, before you guys start putting things away, I see we're all starting to scramble here to put things away. The worksheet that I'm giving you, the new worksheet I'm giving you today, is worksheet 13.5, number 2. You only have to do 3 problems from it. But there's something a little bit different. Okay, it's kind of something very basic. If you don't have your calculator and you don't have your chart, because you lost your chart and your calculator died, how do you find the exact value for the sine of 60 degrees? The main reason is go ahead and you take your calculator right now and hit sine of 60 in your calculator. And you tell me, is that exact? No, I mean exact. What type of numbers are exact? Are numbers that terminate, decimals that terminate, are they exact? Yes, but does this one terminate?
No.
What are these type of decimals called that don't terminate? Or they don't repeat? Non-terminating, no. This is an Algebra 1 concept. Irrational, yes. Irrational numbers, do not terminate. Okay, they do not repeat. So what we're going to have to do is, we're going to have to find the exact value. What type of values, or how can you express an answer so it's exact then, if decimals aren't exact all the time? There you go, fractions. We have to do a fractional answer for this. Okay? And this is actually something, this concept I'm teaching you now is something you're going to use a lot when you get to pre-calculus. Okay, something that I think's on the ACT test too, which I believe is coming up this weekend. Okay, I don't know if some of you are taking it early or not.
Huh? No.
What?
Oh, some of you guys. I always have some of you guys take it 2 or 3 times, and I've had freshmen take it before. All right, go ahead and draw yourself a 30, 60, 90. The one thing I am going to tell you is as I see some of the panic in your eyes here on the first couple, when I do exact value answers, they're only going to be exact values for certain angles. So you don't have to know the exact value of like 42 degrees. Just like when you did special right triangles, there's only a certain numbers that you had to remember the ratios for. Well, those are the numbers that I'm going to use for exact values for trig. If we were to do a ratio here of 30, 60, 90, I'll make the easiest number up here. If this side right here is 1, how much is the hypotenuse? 2. And the
1 times the square root of the square root.
1 times the square root of 3, or just the square root of 3. What's the exact value for the sine of 60?
Square root of 3 over 2.
We have sine. Okay, whoops, I went the wrong side.
Yeah, I was really confused.
Sine is opposite over hypotenuse, square root of 3, all over 2. Go ahead, type in your calculator. Square root of 3 divided by 2. See if you get that same decimal answer as the sine of 60 degrees. Okay, if you didn't have it, then hit sine of 60. Okay, and did you get the same exact decimal?
Yeah. Oh, it's from the
Which one's more accurate? Your calculator, that big long decimal, or this fraction, square root of 3 over 2?
fraction.
Okay. I know you don't like them, but yes. Okay, this is your exact answer. Now, I always have somebody that asks this question. Why did you decide to use 1, 2, and the square root of 3? Okay. Well, you give me a number right now.
4.
4. I'm going to put that on the small side because I want to make your life easy, just like mine. This is 8, and this is 4 squared to 3. What's the ratio of the sine of 60 for this thing?
4 squared to 3.
4 squared to 3 all over 8. What does this reduce down to? Okay, so I'm obviously picking the number up here that's the most simplistic. So when you reduce it, you don't actually have to do any reducing, that you actually get one of the reduced answers. You guys get what I'm saying up there? Okay, so if I asked you to do the tangent of 30 up here, find the exact value for the tangent of 30 degrees. Yes, you would use that same right triangle. On a test, you're not going to have those right triangles. Okay, you're more than welcome to draw it in there and say, okay, 1, 2, square root of 3, tangent of 30, opposite over adjacent is not your answer. Okay. 1 over the square root of 3 is not quite your answer. Okay, we know it that some mathematician a long time ago made your life difficult and said, don't let students put radicals in the denominator. Yeah, what was up with that person? Making your life difficult. And then why do I have to keep on following his rules? Mainly because most of your colleges do that too. And I want to make sure that you've at least seen it. So square root of 3 all over 3. Okay. Questions on simplifying sine of 60, tangent of 30? Alright, I got 2 more here left. Okay, do the sine of 45 and then multiply it by the tangent of 30 degrees. Uh-oh. 45's not in that picture. I mean, tangent of 30 already. Did that one right up here. I have a 30, 60, 90 right triangle. I already know that's 1 over the square root of 3. And how do you do 45? Alright, like I said, there's only certain numbers you'll see me do exact values for. Okay, and those numbers are going to be from your special right triangles. Or something you can manipulate using the special right triangle numbers. Okay, and this one right here, okay, we knew the 45 was 1, 1, and the square root of 2. Remember my mnemonic devices again are the 2 45s or the square root of 2. The square root of 3 right next to the 30. Okay, the 2's are always on the hypothesis. So here I have 1 over the square root of 2. Some of you wasted some of your time because the final answer is the only thing that I need rationalized. Don't rationalize this to square root of 2 over 2 and this is the square root of 3 over 3. Okay, 1 times 1 is 1. Square root of 2 times square root of 3 is square root of 6. And then rationalize it by multiplying by the square root of 6 over the square root of 6. Okay, which will give us our final answer of the square root of 6 over the square root of 36, which is 6.
I kind of multiplied by 1 squared to 2, so I already had it pre-rationalized.
You can, but as you rationalize it right away, there's going to be times then you're going to have to rationalize it again. And some of you will find out on this last example, okay, there's quick ways and long ways to do things. Okay, just so you get the same answer is all I care about. Okay, but the more simplistic you make it, usually the less mistakes you make. Mathematical, arithmetic errors. All right, last one. Simplify this expression. We have the tangent of 45. Multiply it by the sine of 30 degrees and square it all over the cosine of 150 degrees times the sine of 135 degrees and then square that. Okay, so the first thing we have is sine of 45 times, tangent of 45 times sine 30, that quantity squared. The second one we have is cosine of 150 times the sine of 135, that product all squared. Question?
Already answered.
Okay. Anything? Question?
So it's just sine 30 squared, right?
Just, yeah, the parentheses tell you everything up here. You got to be careful on that. You see the difference in the top was I was just squaring the sine. The bottom, I'm squaring the product of the denominator. Now, the top, do I actually take 30 and square that 30 and get 900? So do I do the sine of 900? We've had people do that before, and then they go, well, I don't know how to do the sine of 900. Okay, well, find the sine ratio first. 1, 2, square root of 3. And you will have to put these triangles on your paper, okay, on the test, on the quizzes. Okay, so you got to remember your ratios. Oh, I like the tangent of 45. That's kind of nice. Ooh, cosine of 150, sine of 135. You don't have your calculator there, so you don't have anything to figure those things out. What was true about the sine? We'll do the easy one first. How could we find out the sine ratio?
Sine of 45.
Okay, we know the sine of the supplement, the sine ratios, the supplements are the same as, okay, the original ratio. So if we were to use, okay, that sine ratio, okay, which in this case right here is 1 over the square root of 2, it's going to be exactly the same as the cosine ratio. Is that true for the cosine of 30? Same thing. Cosine of 30 right up here is the square root of 3 all over 2. Okay, big difference here is your obtuse angle is going to give us a negative answer here. We know that obtuse angles for cosine give us, okay, the opposite ratio. Same number, absolute value-wise. Okay, but it's the opposite of it. Don't forget here, some of you, again, don't rationalize the square root of 2 over 2. Okay, don't get rid of that, because you're going to have some simplifying to do here anyway. Okay, and before we square, we need to clear up the parentheses. The parentheses here give us 2 square roots of 2 all over the square root of 3. Can I multiply this 1 and the square 1 and a half together? Or would that violate orders of operations? We have to square before we times. Okay, I know I timesed here, but that was inside the parentheses. Please excuse my dear Aunt Sally. Okay, that's inside the parentheses. Okay, so now I'm going to square, and this is why I went about not rationalizing this bottom, because I have to take the square root of 3 over 2 square roots of 2 and multiply it by square root of 3 over 2 square roots of 2. Square root of 9 over 4 square roots of 4. No, you don't do any distributing. That only occurs when you would have 4 plus x, 7 minus x, something like that, when there's an addition and a multiplication sign. That's the only time that you distribute there. Okay, 2 times 2 is 4. Square root of 4 is 3 times 4 times 2 is 8. So 3/8. So we have up here 3/8 over 1/4. How do we simplify that? 1/4 over 3/8. What are we going to have to do? What?
You have to get 1/4 to come denominator is 3, so just multiply by 2 over 2.
No, we can do it a lot quicker than that. How can we get rid of a fraction in the denominator, Cindy?
I was going to say 1/4 minus 8 there.
Yeah, so we want to get rid of this denominator and multiply by 8/3 cancels it out. gives us 1 in the denominator. We got to multiply by a value of 1. 8/3 over 8/3 is 1. So you're not changing its value, just its appearance. And after all that, nice, simple ratio, 2/3. Got 10 minutes here. I'll just leave that blank here until I see how well you've been working. Okay, so you can work on